8.3's notes have been updated since last year. I decided to actually put what the unit circle looks like with degrees only at the beginning of this lecture, because I want to start off with what is the unit circle. This is a unit circle, and this particular unit circle has all the angles measured in degrees. We're going to expand this unit circle later on when we get to section 6. That's coming up. In section 6, we're going to not just have angles measured in degrees, we're going to actually have angles measured in something called radians. It's a different way to measure an angle. But I wanted to start off with what is the unit circle, and this is the unit circle. It has a bunch of angles and x's and y's on something that would be 1 unit on that graph paper that's up there on the right and on the whiteboard. You may look at this and see all these root 3 over 2's and 1 over 2's and root 2's over 2's and some negatives and things like that, and you might be like, this looks so confusing and this looks very hard to understand, Mr. Prummel. And actually, let me just tell you what my opinion is on it. It's one of the most useful and organized list of common trig ratios for a right triangle. In section 2, we drew a bunch of triangles. We said for a 30, 60, 90, we did this, and we found the x and the y coordinates. That's what we did. We did a 45, 45, 90. We even did a 60, 30, 90, which is the same thing, which is why these are backwards from each other. We also talked about being 1 unit to the right and up and so on. And so if we were to keep going, you would notice that in this 60-degree angle, it has the same reference angle as the 120-degree angle. It's just the same triangle, just over here. So the x component is just a negative x, whereas the x component for the 60 degrees is a positive x. But the y component is the same distance up. Remember that x, that y, and the r? This is what we're talking about. The only difference is there's a negative 1/2 root 3 over 2, and this is a positive 1/2 root 3 over 2. And if you think back, or think about going down to this 240 degrees, the reference angle is the same thing, except we have a negative x and a negative y distance. That's why these are the same things as each other. That's how come the 300-degree angle has the same x and y coordinates as the 60-degree angle, except the x is positive and the y is negative. I'm hoping that sort of makes sense to you, because it's all based off of the same triangles. And so the very first thing that we're going to do is we're going to say, how do I create my own unit circle? That's the first thing that we're going to do. So here's what I'm going to recommend that you do. This is literally what we're going to do. We're going to create a unit circle by going by 45 degrees from 0 all the way to 360. We're going to do that first. Then we're going to count by 30 degrees, not labeling anything that we've counted twice. And then we're going to write all the cosines, thinking of 1 as root 4 over 2, and the pattern descends. And then we're going to write all the sines. I'll explain what that means. And the triangles are the same size when they have the same reference angles, and they'll have the same cosine-sine ratios, and the sines depend on the quadrant they're in. If you do not know what that means, you may want to look at that as we do this. You have one of these in your, something like that in your notes. It's blank. Turn the page if you have not seen it yet. There is a blank unit circle. And so the first step is I need to know how to label or create my own unit circle. What you saw me give you the example, you need to be able to create one from scratch. So here's how I would recommend you do it. The first thing we're going to do, says it right here, label all angles by 45 degrees. Here's what that looks like. Right here, at the initial ray, you put 0 degrees. I'll point an arrow to it so you can copy it down as I am pointing to it. Then 45 degrees is halfway to 90, so that's this red one in my picture. For you, it's that diagonal that's right down the middle. 0 degrees, 45 degrees, and I need to go another 45 degrees, which puts 90 degrees straight up and down, which should make sense to you. Add 45 degrees to that, and the middle one over here is 135. And you're just going to go right around the circle. Add 45, guess what that is? 180, 225, 270, 315, and then right below 0, I also add and go all the way to 360 because 360 and 0 are coterminal with each other. Does that make sense? The first thing I do is go all the way around by adding 45 degrees to all the 45 degree angles. The second thing you do, you're going to do the same thing except with 30 degrees. 0 degrees. 30 degrees is this one right here. We skip the 45 because we're not going by 15, we're going by 30. If I go 30 plus another 30, that takes me to the blue. 30 plus another 30 is 60. 60 plus another 30 is 90. I already have that there. Plus another 30 is 120, plus another 30 is over on the green, 150, plus another 30 is 180, plus another 30 is 210 on the green, plus another 30 is 240 on the blue, plus another 30 is 270 on the axis, plus another 30 is 300 on the blue, plus another 30 is 330 on the green, plus another 30 is 360 back to the x-axis. So now we have all our angles. I'm waiting for you to catch up if you haven't done so already. These are the angles that we're working with in degrees. It's fairly simple. You will get used to these numbers the longer that you do it. And then what I recommend is this is a unit circle, meaning using one single unit. I think it's easiest to do the axes next. Well, let me actually read what I wrote down here. It says, write all the cosines in quadrant 1. Think of 1 as root 4 over 2. We went 1 unit to the right. Here's your cosine. Here's your x-coordinate. It's a 1. And I said think of 1 as root 4 over 2. Because it's just a pattern. And this is the fastest way to do it that I know of. Root 4 over 2, next cosine, root 3 over 2, root 2 over 2, root 1 over 2 simplifies, root 0 over 2 simplifies. So let me say that again, and I'm going to zoom in because I know that it's hard to see. This is root 4 over 2. Which is the same thing as 1. It simplifies. The square root of 4 is 2. 2 divided by 2 is 1. Root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2 simplifies, and root 0 over 2. It's just a pattern. It descends. Cosine going up the circle because your x distance is getting smaller as you go. Now, the pattern is the exact same thing with your sines, except I like to start at the 90. Root 4 over 2 simplifies. Root 3 over 2. Root 2 over 2. Root 1 over 2. Root 0 over 2. And I have all 5 coordinates in quadrant 1. If you haven't written those down yet, please write them down. In my particular graph that you see here, the thing I want you to realize or look at, because what we've done is we've done this, we've done this, we've done this, we've done this, we've done this. We've done these 5 lines. All we have left to do, triangles are the same size when they have the same reference angles. Therefore, they will have the same cosine and sine ratios but their signs depend on the quadrant they are in. Here's what I mean by that. See this green angle that I have here? It connects over here, and this green angle and this green angle, and I have this one labeled as red, and that one is blue and blue because they have the same reference angles. What's a reference angle? That's the positive acute angle formed to the x-axis. This angle is the same as that angle. It's the same triangle, which means the x and the y are the exact same ratios. This green angle here is the same over here. This x is the same as this x over here for 150. 30 degrees has the same x as 50. So I'm going to put root 3 over 2 for my x because that matches. And my y is going to be 1/2. There's only one difference. We're talking about going to the left on graph paper. On graph paper, your x is negative, your y is positive. This should be negative root 3 over 2. And the y is positive. These match. The x coordinate, this becomes negative. What's positive? The sine. What's negative? The cosine. I'll put that up there in that little chart. The 30 degrees and the 50 degrees match. The 45 and the 135 will match, except the cosine is negative. I look over here, it's root 2 over 2 and root 2 over 2, except the cosine needs to be negative because we're going to the left and then up. The 60 and the 120 degrees, negative 1/2 up root 3 over 2. What's positive over here? Cosine's positive and the sine is positive. They are both positive. I've done quadrant 1, I've done quadrant 2. I just have quadrant 3 and quadrant 4 to do. And just like the 30 degrees was the same reference angle for 150, it's also going to be the same for 330 and for 210. That means the x stays the x, the y stays the y. The only difference is the sign for the quadrant that it's in. Root 3 over 2, root 3 over 2, 1/2. Root 3 over 2 is positive, the y is negative. Negative, negative over here. I'm hoping you see how it's done. It's the same ratio, except I just have to say, hey, I went to the right, it's positive, down, negative. Or I went to the left, negative, down, negative. And so I'm going to copy everything else. Negative root 2 over 2, negative root 2 over 2. It's the same pattern. Negative 1/2, negative root 3 over 2. Over here, same thing, 1/2 positive, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and 0, negative 1, because we went down 1 unit, to the left 1 unit, 0 units up. Did I do the other one? I did. What's positive here? Nothing, technically tangent. What's negative here? Cosine is negative and the sine is negative. What's positive here? Cosine is positive. What's negative here? Sine is negative. And I probably should throw in tangent as well. Tangent is negative. Sine, tangent. Make sure that I can read that. What's negative here is cosine and tangent. There we go. Just so we're aware. You should be able to create your own unit circle. I'm fully expecting you to be able to. You technically now know, hopefully, that this is based off of special right triangles that we learned back in Unit 7. It's just now we're dealing with the circle. And it's very easy to do some of the problems if you have a unit circle. That's the next aspect. So make sure that you are able to do this. This is on your quiz. This is on your test. Are you able to create a unit circle? I won't have you make a whole one. I might just pick a quadrant and say you have to figure out, if you have this form, you'll do this quadrant. If you have a different form, you'll have to fill in your own on the test. Okay? And then here's the question. So the first idea is, how can you create it? The second idea that I need you to know is, well, how do you use it? If it says the sine of 120 degrees, sine is the y-coordinate. All you have to do is go to 120 degrees. You go down that angle and you're looking for the y-coordinate. If you can't read my handwriting, then maybe we just go to this one here that's really nice and neat. Here's 120. The y-coordinate is positive root 3 over 2. We write root 3 over 2. If it says cosine of 210 degrees, you go to 210, you look for the cosine. This cosine is negative. It can have a negative ratio. The reason it has a negative ratio is because it's in quadrant 3. You're going to the left. It's negative. You go to your unit circle for cosine of 360 degrees. The cosine coaxer is your x. I say it that way because that's how I remember it. If that helps you, use it. Cosine of 360, the x-coordinate is 1. And do you notice there's not a lot of work to do? You're just looking at the angle and then you're looking for the ratio. So the only way this gets hard is if I ask you for a tangent. Tangent of 120. Here's 120. Tangent is the sine divided by the cosine. This divided by that. And remember, I showed you a long way, and then there's a short way. The long way was root 3 over 2 divided by negative 1/2. The short way, root 3 over negative 1 is negative root 3. If it's not rationalized, if it was the other way around, you would have to rationalize it. But I kind of do that in my head. So the last thing I want to say, first thing, you have to know how to create a unit circle. You have to know how to use the unit circle. Let me go back to that very, very beginning thing. I told you earlier that this is one of the most useful and organized lists of common ratios. Think about what this is telling you. Do you remember how we just did these problems and we found the sine of 120 is root 3 over 2 and the cosine of 210? Think about every single thing that we did. This picture here represents, if I asked you to find the sine of 30, what would that ratio be? If I asked you to do the cosine of 30, what would that ratio be? If I asked you to find the tangent of 30, what would that be? And this is a list of all the ratios kind of sort of overlapping each other. If you think about what I've asked you to find, the sine of 30, or the cosine, or the tangent, and I were to write it out in list form, look at what this would have to look like if I had you list it out in a table. This table is huge. It's gargantuan. Instead, what some genius did, somebody a whole lot smarter than me and you, they said, what if we put it in a circle? That way we can just keep going around the circle and see these ratios are the same over here as over here as over here, except we just put directions. And then we know the sine and the cosine and the tangent organized. I think it's very helpful. I hope you can appreciate it. It's way better than a list. That's where I'm going to end your notes.